Hi everyone, this video is going to be over conic sections, the hyperbola. So what we have here is we're given the standard form, and they're both set equal to 1, but what we need to pay attention to is now that there is a minus sign in the middle. So when x squared comes first, then the hyperbola is going to open left and right. When the y squared comes first, it's going to open up and down. So we find the center the same way we've been finding the center every single time. H, K, making sure we take the opposite signs. But now you have to be cautious because if the y comes first, then that is the k value because h is always with the x and k is always with the y. So you have to be cautious when you're identifying the center, making sure you're taking the h from the appropriate spot and the k from the appropriate spot. So then we have our transverse axis and our conjugate axis. These are very similar to the major and minor axis from the ellipse, but it's just a tiny bit different. So this is the line that connects the two vertices. So your vertices of your hyperbola will always be on this transverse axis, and if you want to find the length, you take the square root of a and then you multiply it by 2. Okay, and it's always the first denominator. The conjugate axis is perpendicular to the transverse axis and it goes through the center. So again, once we get to these, I will show you what this looks like. Okay, the length of that would be the square root of the second denominator times 2. Then we have our foci. So depending on how it opens, if it opens left and right or up and down, determines how you find the foci. Okay, and then again, we have this formula, and it's not a typo. This time it is c squared equals a plus b squared. So keep that in mind. So going into our first example, what we have here is first thing, let's determine how the hyperbola opens. So notice that our x is coming first. Since x is first, it is going to open left to right. So I'm going to write, since it's x squared minus y squared, okay, that means it opens left, right. Okay, which means it's going to be horizontal. Okay, so first thing we're going to do is we're going to identify our center. Our center comes from the numerators. So h is with the x, k is with the y. We take the opposite sign, so we get a positive 2, negative 1. That is our center right there. So what we're going to do is we're going to plot that point to negative 1, which is right here. So now what we do is we look at the denominator under our first fraction. So right here, that is 25. That means a squared is equal to 25. To find a, we take the square root and we get 5. So from our center, we're going to go left 5 and right 5 because it's under the x variable. So from my center, I go 1, 2, 3, 4, 5. I put a point, and 1, 2, 3, 4, 5. I put a second point. Okay, this is going to be our vertices. What we just created is our transverse axis right here. So from vertice to vertice through the center is our transverse axis. So the length of that transverse axis is 5 plus 5, or 2 times 5, which is 10. So from vertice to vertice, it is 10. So I'm going to show you that it's 2 times that 5 that we just got as the A, which equals 10. Now, a couple things that I can go ahead and fill in is that the orientation we said earlier is going to be left-right. It's actually both directions, and once we graph it, you'll see what it looks like. Okay, and then I just got the vertices, so I can go ahead and label those. The vertices was -3, -1, and then the second one was 7, -1. So notice how we got that is we took our center of our center of 2, and we added and subtracted 5 from that x value because this is a horizontal hyperbola. Okay, so now what we're going to do is we're going to look at the denominator of our second fraction. This is our b squared, which is 36. We take the square root and we get 6. So from my center, I'm going to go up 6, put a point. From my center, I'm going to go down 6 and put a point. So what we just drew here, if we connect the two dots, is that conjugate axis. So let's label that. Okay, that is our conjugate axis. So how we get our hyperbola from here, what we're going to do is we are going to connect the dots and we're going to make a rectangle, out of all of these points that we just had. So like this. Okay, so we made that rectangle. Then what we're going to do is a hyperbola actually has two asymptotes. We're not going to focus too much on those asymptotes, but it goes from diagonal of that rectangle to the other diagonal through the center. Okay, so this right here would be an asymptote. Again, I'm not going to make y'all find these. And then from this corner to the other corner diagonally is the second asymptote. Boom. So then all we need to get the hyperbola is we just need to draw one sideways parabola through this vertice getting close to that asymptote, like that, and then another one from the second vertice getting really close to the asymptote, like that. And that's all a hyperbola looks like. Okay, so for the foci, remember we have a different formula. This formula is now c squared equals a squared plus b squared. So we take c squared and we have 25 plus 36. When we add that together, we get c squared equals 61. We take the square root of both sides and we get c equals the square root of 61. 61 cannot be simplified, so therefore it will stay the square root of 61. So for our foci, we're going to take our center and we're going to add the square root of 61 to the x value because it is a horizontal, because it is a horizontal hyperbola. And then we're going to take our center and we're going to subtract it from the x value of our center because it is a horizontal hyperbola. And so our foci is 2 plus the square root of 61, comma, -1, and 2 minus the square root of 61, comma, -1. The one thing I have not answered that I forgot was the length of the conjugate axis. So that, remember, we went up 6 from the center and down 6 from the center. So if we take 2 times 6, that gives us the length, which is 12. And that is it. So what I want you to do is I want you to pause the video, try example 2, see how you do, and then check your answers with what we have. So hopefully you gave this a try, you paused the video. We see that the y squared comes first, which means that this is a vertical hyperbola. So since it is y squared minus x squared, that means that it's going to open up and down. So this is a vertical hyperbola. So since we know that, we can go ahead and write that orientation. It's going to be up and down. Okay, to identify the center, it is h comma k. So h is with the x, k is with the y. So the center should be a -2, 3. So hopefully you did not mix that up. When you plot that, -2, 3 is right here. Then you look under our first denominator. Our first denominator is 4. So that means a squared is equal to 4, which means a is equal to 2. So from the center, I'm going to go up 2, put a point, down 2, put a point. Those are my vertices. So I'm going to go ahead and label those. So I have -2, 5. Notice how the x value of our center is now staying the same and our y value is changing. So it was 5. The second one was -2, -1, or sorry, +1. So notice that when to get these, let me move these next to each other, put and in the middle. So notice to get these, all we did was we took our center of -2, 3, and we added and subtracted the 2 from that first denominator. Okay, that's where our vertices lie. So that is our transverse axis from vertice to vertice. That is 4 units. So that was 2 times 2, which is 4. Okay. Looking at the next one, we need to look at our second denominator, which is 16. That tells us that b squared is equal to 16. So b is equal to 4. So from our center, we're going to go to the left 4, put a point. From our center, we're going to go to the right 4 and put a point. Those are not anything except it helps us build the rectangle that we need to get our asymptotes so we can draw our hyperbola. So I draw my rectangle. Then I'm going to connect the diagonals, so diagonal to diagonal, to get my asymptote. Again, I'm not going to make you find the equations of these asymptotes, but there is a way to do it. So here to here. Okay, we said it opened up, down. So I take my vertice, I go up. I take my vertice, I go down. And it looks something like that. Okay, the rectangle that we actually draw is not part of the graph. It's just a way to get those asymptotes without having to find the equation. So I did not find the length of that conjugate axis, so that was the red point. So from red point to red point, okay, I went over 4 to get to the center and then another 4 to get to the other side. So the length of this conjugate axis is 2 times 4, which is 8. Then we need to find the foci. To find the foci, we use c squared equals a squared plus b squared. So that would be c squared equals 4 plus 16. That gives me c squared is equal to 20. I take the square root of 20, and I get c is equal to the square root of 20, which breaks down to the perfect square of 4 times 5. Well, the square root of 4 is 2. The square root of 5 stays there. So I'm going to add and subtract 5 from the y value of my center. So I have -2, 3, and I'm going to add 2 square roots of 5, and then I'm going to subtract 2 square roots of 5, and that's how I get my foci. Okay. So looking at the next one, I'm not going to worry about graphing as much as I am going to be about completing the square, and then you can pause the video and find all the information we need to find. So here we go. This is in general form. I know how much y'all love general form. Okay, so when it's in general form, that's where we have to put it into standard form, which is the form we like because we can get all our information. So what I'm going to do is I am going to rearrange my variables. I have 4x squared plus 24x plus space minus y squared plus 4y plus space minus minus 4, and then we're going to have a minus space and a minus space for our other one, and it's still set equal to 0. So here we go. One thing I do need you to know from general form is that there's 2 variables squared, which means it can be an ellipse, a circle, or a hyperbola. But what makes it a hyperbola is that one of the variables is negative. Okay, my signs are different. This one, the x squared is positive, the y squared is negative. Okay, so what we're going to do is we're going to focus at one variable at a time. So we see this has a GCF. So we're going to factor that GCF out, which is x squared plus 6x plus space. We take half, so half of 6 is 3. Then we square 3, which is 9, so a 9 goes here. But you have to remember to take 4 times 9 to get 36, so that's what goes there, which means it also goes there. So now we can do our shortcut where we take our parentheses squared. We have to remember that GCF we factored out, and we have x plus our half term, which is 3. So the first half is done. Now we go to the second half. The second half, you should notice that the y has a negative in front of it. So we need to always factor out a negative of our second variable that we're doing this with. So we have a -1, which means this changed to a positive y squared, this changed to a -4y, and this can stay the same like that. Okay, so because that y had a negative, you have to factor out a -1. So we're going to take this term right here, and we're going to take half of it. So half of -4 is -2. Then we square it. When we square it, we have to make sure that that negative goes inside the parentheses, and we get +4. So a 4 goes here, but I have to remember to multiply it by that -1, which makes this a -4. So that means a -4 is going right here. So then I have to do my shortcut. So I have parentheses squared. I have that GCF of -1 out in front, and I have my variable and my half term. Then all I need to do is combine these three terms right here by adding. So I have -4 minus 36 minus a -4. Well, this right here really turns into a double negative, so that's actually a +4. So -4 minus 36 plus 4, well, the two 4's cancel each other out, and it leaves me with a -36. And then it's still set equal to 0. So what we do here is we're going to move that 36 to the other side. So that gives us 4 times x plus 3 squared minus 1 times y minus 2 squared equals 36. It has to be set equal to 1. So all we're going to do is divide each thing by 36 and simplify the fractions. So 4 over 36 simplifies to 1 over 9. That's going to stay 36, 1 over 36, and that's going to simplify to a 1. So our standard form is x plus 3 squared over 9 minus y minus 2 squared over 36 equals 1. That right there is our standard form equation. So go ahead and pause the video and find the center, the foci, the orientation, the vertices, the length of the transverse and conjugate axis, and then check your answers. So hopefully you paused the video and you got that the center was -3, 2. The orientation is going to be left, right, because the x comes first. Okay, the foci, when you solve the c squared equals a squared plus b squared, you should have got the square root of 45. The square root of 45 breaks down to the square root of 9 times 5, which is how we get it to be 3 rad 5. The square root of 9 is 3. The square root of 5 is not perfect, so it stays the same. So since it is a left-right one, we're going to add and subtract that from our x value of our center. So it's going to be -3 plus 3 rad 5, comma 2, and -3 minus 3 rad 5, comma 2. So let me make that a little smaller, scoot it over some. Boom. That is our foci. Our vertices, okay, only affect the x value of our center again because it is a left-right parabola. So the vertices you should have got were 0, 2, and -6, 2. The length of our transverse axis, that would be the square root of the first one times 2. So square root of 9 times 2. So that would be 2 times 3, which is 6. And then our conjugate axis would be the square root of our second denominator times 2. Square root of 36 is 6 times 2, and we get 12. So real quick, I can graph this for you. So we have our center at -3, 2. Okay, our first denominator says that we go to the left 3 and to the right 3, and that's where we get our vertices. And then my second denominator tells me that I go up 6 and down 6. Okay, that right there gives me the information I need to build the rectangle so I know where my asymptotes are. Boom. Again, I'm not going to make you find the asymptotes, but if I'm helping you graph, might as well graph them and show them in there. Oops. Boom. Fix this one just a tad bit. There we go. Okay, So it is a left-right parabola, so therefore it's going to go here, or hyperbola, this, which is basically two parabolas together. Boom. Ooh, that's really bad. There we go. So it should look something similar to that. So what I want you to do is I want you to try example 4, pause the video, see if you can complete the square to do it. And I'm just going to give you all the answers, and if you have questions, you can make sure you ask. So here we go. Hopefully you paused the video, gave it a try. The standard form equation that you should have got is y plus 1 squared over 16 minus x minus 2 squared over 9 equals 1. That is our standard form equation. Being very careful with this when you identify the center. So the center should be 2, negative 1. Because y is first, it is an up-down hyperbola. Your foci should be at 2, 4, and 2, negative 6. Your vertices should be at 2, 3, and 2, negative 5. The length of your transverse axis would be 2 times 4, which is 8. And then the length of the conjugate should be 2 times 3, which is 6. So if you have any questions on any of this, please make sure you write it down and you ask in class. If we graph this real quick, we had our center at 2, negative 1. From that, we went up 6 to put a point, and down 6. That's how you get the transverse axis. Then we went left 3 and right 3. And now I just realized that it should not be up 6 and down 6. It should be up 4 and down 4. So let me fix that. There we go. 1, 2, 3, 4. Okay, if I build the rectangle to help me get my asymptotes, so we don't have to find the equation. Boom. Draw in my asymptotes from here to here. And we said that it opened up, down, so it would look something like this. Boom. And that would be our hyperbola. So if you have any questions, make sure you write them down. And that's it for this video. I will see you in the next one where we talk about classifying the different conic sections.